Assalamu alaikum. Today, I'm here to present a big data analytics final project presentation on our project number 2, Spark, MlLib versus Apache Mahout. My name is Faizan. So this is a system configuration that I've used on my system to utilize the Docker and system to run the Apache Spark and Apache Mahout on my laptop. So this is the system configuration that has been noted in the report. Second, the Docker desktop has been set up and configured on which I have used the containers and images are presented in front. For the Spark master, I've used a Docker compose file, which has enabled it to pull from it, and I've also included in the YAML file. Introduction to Spark, MlLib, machine learning library versus and Apache Mahout. So Spark ML, Spark is a scalable machine learning library consisting of common learning algorithms and utilities. It includes both kind of classification and regression problems. It can also enable us to clustering, collaborative filtering, dimensionality reduction, and underlying optimization primitives. We use PySpark for it to implement, and it is based on an API for utilizing the Spark framework in combination with Python. For Apache Mahout, it is a distributed linear algebra framework which uses mathematical expressive scalar DL design, and it is also recommended to go out of the box distributed backend and other distributed backend mechanisms. So it supports both of them. Coming to the part for the implementation of it, I've used Docker run command to implement and open the PySpark notebook. Here we have got the link that enables us to be pasted into the browser for us to have access to the PySpark notebook. This is the new PySpark notebook on which we will continue to work. Container from the pull from the Docker, and we can also have a look at our container in the Docker list. Here is the screen of which we can see there are many containers that are running at the moment, which we will see in our presentation ahead. Coming to the part now, the next part is now that I've used this is the part where we have uploaded the data on PySpark, which enables us to have access to load it for further implementation of machine learning algorithms. I've used a dataset that is consisting of 400 MB. Using the import session of PySpark SQL, we have enabled it for further implementation. Now coming to the part of loading the dataset, I've loaded the dataset using the Spark read command, and the dataset has been loaded. I have visualized the data frames and data types of my data frame, which I've loaded, and its summary that gives us the statistics of mean, median, standard deviation of all the features that we have in our data frame. Further coming to the part of feature importance, I have visualized the features that that I have in my dataset, and based on its importance, we have further worked on to select the features that would be more useful in giving us an accurate test and training results. So coming to the part, I have selected the columns that are required for us to work on, and I have also visualized it using the .show command that gives us the visualization of the data. Coming to the part using vector assembler, it is used to select the input and output to column features based on our required features that we need to provide, and it transforms them to be further used in the test and training split to fit the model. Then we have further split our data using train and test split. I've used the 70-30 ratio, and also I visualize the training data. Coming to the part of correlation metrics, I've used the correlation metrics also it also gives us the correlation between the features and importance of it that visualizes us and gives us an idea on which features are the most important ones. Coming to the part of training the model, I've used 5 different machine learning models using the library of Spark MlLib, and have fitted the model based on, first of all, I've chosen the random forest regressor on which it has been fitted, and the execution training time has also been recorded, which is printed over here. I've also calculated the RMSE and R squared test accuracy scores. Based on that, I've printed both of them, and which will be further used for the performance comparison. Here, I've also visualized the random forest regression plot against the price and the prediction that it is giving us on the test data. So the performance of R squared is also printed over here, which gives us an idea of how our model is working on. Further, I've used linear regression. Linear regression is the same work. We have used different parameters that the linear regression have, and also have calculated the execution time of it. And the extra thing that we have done on that is I've also calculated the coefficients and intercept of the model that linear regression gave us. I've also calculated the R squared and RMSE square of linear regression, and this is the performance visualization that it gave us against the price and prediction of based on the test data that we have. The same that I've done for the third machine learning algorithm that I've used is gradient boosting regression, and based on that, the pipeline is set, and all the parameters that are being given to it are further used for the fitting of the model. I've also calculated the time for it and visualized the gradient boosting regression graph, which gives us the most accurate results by far. Then I've also used decision tree regression, which gives us all the statistics of its execution time, R squared, and RMSE score. I've also used the fifth algorithm that I've used is k-means algorithm. So based on that, I've also calculated the execution time, and based on different distances, I have calculated all of them, and the R squared value for it is all calculated on that. Here I've compared the performance comparison of different models, and based on its execution time, RMSE score, and R squared, I've compared all the models that we have. Coming to the part of data visualization, there are the dataset that I've chosen is housing dataset, which has many features that are correlated to each other and gives us the pattern based on its feature importance. So I've also lined out most important features based on that. The price varies on, for example, we have bedroom, the year the house is renovated, and the grade of the house on which it is being sold. This is visualization of the data. Now coming to the part of running Apache Mahout in Docker, I have used the link that you have shared with us. I have used the Docker pull command to pull the container of Mahout, and then same running it Docker using this command Docker run. I have opened the Spark shell of Mahout, that which would be further used for the implementation of machine learning algorithms. I've used the import command for the linear regression. The thing that the data needs to be loaded into the container, I've used the following command Docker cp, which is the housing.csv of our dataset, and this is the container name on which the pull has taken place / Apache, which enables this dataset into our to load the data into Apache Mahout. For the implementation of simple linear regression, I have used the Apache.mahout or MAD algorithm regression using ordinary least squares. I have provided dataset to parallelize, and it then is the dataset based on our .csv value. It gives us a data limited value, and it loads it into the visualized the features of that. I have distributed the dependent and independent variable. Here we have 16 independent variables, and the price is the target variable, which has been for further Mahout DSL automatically optimizes and parallelizes all the operations. I've used the commands which fits the model, and it collects based on the implementation or in a distributed linear algorithm, and the Mahout provides an analog solve function for which that computes the estimate, the OLS estimate of the parameter vector. Here we can see we have fit the model, and based on that, we get the norm score for L2 norm score. The goodness of fit is the name that I've used for a function which comprises all the code, and it gives us the score, the goodness of the score based on that. For further, I have used ordinary least squares, which gives us the multiple parameters based on that calculation common statistic. If it is kept false, it will only give us the common statistics value based on our model fit. For if I have set it true, which I have also done in that, it gives us the stats p value, mean squared error, and r squared error, which can be visualized below. Read data using a Spark read data created a pipeline which gives us the linear regression type, and it is also used for implementation of machine learning algorithm. So in conclusion, the main difference lies in the framework. For Mahout, Hadoop MapReduce is in the case, and Mahout has proven the capabilities that Spark MlLib is mature when it comes to machine learning algorithms to choose from and to build upon a MapReduce model. Where we have compared the performance of Spark MlLib and Apache Mahout on different machine learning algorithms and recorded their performance based on execution times and measuring statistics and errors. Thank you very much.